Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Very good morning. The topic of our paper is about lean implementation barriers and their contextual relationship in contract manufacturing precision machining company. This paper is written by Raja Surian and myself, Syed Helmi. We are from the Faculty of Mechanical Engineering and Center for Engineering Education, University Technology Malaysia, and also written by Professor Muhammad Hisjam from the Department of Industrial Engineering, Faculty of Engineering, 11 Maret University, Surakarta. When we talk about lean manufacturing, which is a revolutionary production concept which was originated from Toyota production team. And the principles of lean manufacturing is to synchronize the product needs and requirement at the scale of production, while at the same time reducing the wastage in production. It was started by Ahmad from Toyota, where he discovered several types of waste in product manufacturing by the company, and he deduced that by eliminating waste in mass production, both the quality and production flow of product will improve greatly. There are many lean barriers in the implementation, which can be divided into financial barriers, top management related barriers, workforce barriers, and also some other barriers. For the financial barriers, there are possibility of the unnecessary investment, high investment, and also for the top management related barriers, there's a possibility of poor communication from the top because of the poor understanding or poor belief in the approaches and advantages. While for the workforce related barriers, there's a possibility of poor communication from the bottom up because of the fear from the employee and some other reasons. The other barriers might be because of the multiple production system that the company have, and also the difficulty of quantifying the benefit of having lean implementation. For the problem statement, in this company, there is no proper implementation of lean manufacturing, and many times the lean initiative are stopped without complete the target, and there is no definition of lean responsibilities among workers in terms of their job scope. Because of that, there's a lot of issues of pinpointing in lean responsibilities ownership, and there is no basis to identify barriers and to tackle the lean management systematically. So the study of our project is to identify what are the critical barriers in lean manufacturing implementation for the company. Then from there, we want to establish the contextual relationship of critical lean manufacturing implementation barriers and to propose a procedure for successful lean manufacturing implementation. The study is carried out in one of the contract manufacturing small and medium scale enterprises, which is a precision manufacturing company, and the case study will focus on the production and operation management. So this study our intention is to answer the following questions. what are the critical barriers of lean manufacturing implementation in contract manufacturing precision machining industry. That's the first one. The second one is we want to look at what are the relationship between each pair of these barriers, and then what is the suitable strategy to ensure the successful of lean implementation to the company. We review several papers which impact highly in relation to this study and their finding. From this paper, we have identified 15 barriers of lean manufacturing, and the barriers, for example, poor top management direction and support, lack of long-term commitment to change and innovation, lack of training, poor facility layout, lack of information and data sharing, poor sales focus, roles and responsibilities not defined clearly. These are the papers, example of the papers that we have reviewed and the barriers that was related to that paper, mentioned in that paper. For the methodology, in this study, we use the ISM, which is the Interpretive Structural Model. We generate the model based on this ISM, and then we analyze the drive power and dependence power of the barriers using MICMAC analysis. And then from this MICMAC output, we identify the roles of the barriers that were played in the implementation of the lean. In MICMAC analysis, we analyze the result of the ISM model and identify the drive and dependence power of the barriers. Based on the drive power and dependence power, we classify the factors into 4, which are the autonomous, linkage, dependent, and independent factor. These are the structural self-interactive matrix, where we map each of the matrix to compare the relationship between each other. The V stands for barriers I influence barriers J. A is the barriers J influence barriers I. The X are the barriers, which means that barriers I and J influence to each other. O means barriers I and J do not influence each other, have no influence with each other. From the structural metric, we develop the initial reachability matrix. For example, here the V barriers where barrier I influence barrier J. So we convert it into a binary of 1 and 0. For V, we change it to 1. For A, means that I influence J. For A, where J influence I, so the entry is JI. We put it 1 for JI. And then for X, where barrier I and J influence each other, so both IJ and JI, we put 1. And then for barriers I and J do not influence each other, we convert that into 0. And these are the example of these are the initial reachable metrics, and we calculated the drive power for each barriers. For example, the poor top management directions and support, the total driving power is 9, and total independent power for that is 5. And we calculate for all the barriers in terms of their driving power and also their dependence power. From this initial reachability matrix, we reconstruct the matrix by look at the transitivity. The transitivity means that, for example, if A1 have relationship with A2 and A2 have relationship with A3, it means that A1 have a transitivity relationship with A3. So from the initial reachability matrix, we include this transitivity, and because of that, we recreated the matrix, and these are the recreation of the reachability matrix, which is the final reachability matrix. By including this transitivity, we reconstruct the matrix, and this is the final reachability matrix. And because we include the transitivity, we can see here the driving power, numbers of the driving power and the dependence power have changed as compared to the initial reachability matrix. From this final reachability matrix, we develop the MICMAC analysis. So from the MICMAC analysis, we have to identify the position of for each of the barriers. For example, here the role and responsibility is not defined, so the position is 15.1 based on the driving powers and dependence power, and we identify all the position for the factors. And these are the position where we divide into 4 quadrants, and each of the barriers are located based on their driving and also dependent factors. We can see from that MICMAC quadrants, cluster 1, which is the autonomous variables, and from here there is no barriers that is located at these autonomous variables, where it means that the factors have a weak drive power and also weak dependence power. But we have barrier 12, 13, 14, and 15 for cluster 2, which is the dependence variable, where these factors actually have a weak drive power but strong dependence power. And we have several barriers that is located at cluster 3, which is the linkage variables. And here the factors have a strong drive power as well as strong dependence power. And we have 1, 3, and 4 barriers located at cluster 4, which means that this is the independent driving power, where this factor have a strong drive power but weak independence power. These are actually called the key driver. This is the final reachability matrix that we have identified earlier. From the initial reachability matrix, we will develop the ISM model. To develop this ISM model, we have to do the level partitioning. We convert the initial reachability matrix into the following table. If you can see the table here, we divide the table into 3 columns, which is the reachability set, the antecedent set, and also the interaction set. The leveling is based on the similarity in the reachability set and also the interaction set. As you can see from this table, variable 15, which is the barriers number 15, can be eliminated because they have the same set in RS and IS. So this will be the first level that will be located in the model. Okay. And these are the sets after eliminating the first level, which is barrier number 15. The second level will be barriers number 14, where we have the interaction set and reachability set are the same. So that will be level number 2. Okay, and we eliminate that level 14, barrier 14. Once we eliminate the barrier 14, then we have the barrier 13, because the interaction set and the reachability set of variable 13 are the same, so we can have this as the next level, which is level 3, and then we eliminate this from the table. So now we have level 4. Since level 4, where the variable number 12 is the level 4, which have the same interaction set with the reachability set, and because of that, barrier number 12 will be the next level, followed by barriers of 10, which is level 5, and barriers number 8, which is level 6, and then at level 7 we have two sets which have the same reachability set, which is barrier 9 and barrier 2. So barrier 2 and barrier 9 will be at level 7. So you can see here, level 7 have two barriers. The same goes with level 8, which have 4 barriers that have the same sets. The interaction set have the same set with reachability sets. And level 9 consists of barrier 3, and the last level, which is level 10, have barriers. We have barriers number 4 and number 5. So from here, once we have done the level partitioning, we can translate that into the model development. This is the model based on the level partitioning, and we can see here level 1, which is the roles and responsibility, is not defined in Lean implementation, followed by level 2, which is the wrong selection of Lean tools, until level 10, which consists of lack of long-term commitment to change and innovation and individual attitudes. From this model, we can see that level 10, which is the most important level, is the fundamental or the foundation of the other barriers. So from here, from this model, the ISM method has actually transformed the Lean barriers from qualitative into quantitative, and you can see the interaction between the barriers in the model structure. So you can see here that the barriers are classified into 10 levels with the respective barriers, and these levels can be tackled in a proper set time phase. So all the 15 Lean implementation barriers were classified using the ISM techniques and MICMAC analysis. And from this generated model, we can clearly identify that the most significant barriers are barriers number 4 and 5, which is at the level 10. And these barriers are the base for this ISM model. Typically, they will display a weak dependence power and strong driving power, whereby level 15, which is at level 1, has the highest dependent power, followed by level 14, 13, and 12. So for the conclusion, by having a firm understanding of Lean implementation barriers and their contextual relationship, a reliable Lean strategy can be generated. Through this implementation, the benefit of Lean of identifying ways can be done by organizing the continual improvement, and then by identification and elimination of non-value added activities actually can result in a very uh, high impact of the operation costs for the organization. So given that the current market direction towards implementation of green practice with environmental effect consideration, successful lean implementation is very important and have a positive impact toward the environment. The repetition of these studies, this actually was focused on a single management-based organization. And the other limitation is the study is actually based on local company, and which is from the management perspective on barriers. The result actually could vary from one company to another due to many factors such as the local environment, education level, and so forth. So for the future, this study actually can be further validated with other companies by more experimental factors between different companies under the same organization for the improvement. Validation of the model, particularly with other sectors, by using exploratory factor studies also can be done to improve the study. Thank you.